So hello everyone. Let's start with the neural network basics. Okay. So I think this is very favorite topic. I think this is in fact my favorite topic as well when it comes to deep learning, because the neural nets is similarly it's more of a how your actually brain works, right? So it basically like started in the area in the year of 90s, where like people started using a biological neural network, right? So BNN, right? So they wanted to transmit some kind of a message, right? So and these are actually the neurons we have, right, in our brain cell. So let's say that they wanted to transmit something, right? So neurons is actually the very best way of in order to transmit some information points, let's say from point A to point B, right? The same kind of a concept they have actually used it and implemented using something called as neural network. Okay, so neural network, as I already told you, that neural network is basically the some kind of a sub, like in deep learning, whatever model that we are training on the skeleton of neural network, right? Now, before understanding and before diving it into the, let's say, neural network, I just wanted to ask you some question. Okay, I have prepared some kind of a good things for you, right? So let's say that suppose if I wanted to make you good tea, right? Now, what will you do? Like you have a milk, you have a sugar, you have a tea leaves, and you wanted to pass some extra material. You can actually do it by yourself, right? So what will you do? You'll go to the kitchen, like you try to pick up these many things in some x amount, right? And then you are again like putting all these things together, and you wait for some time, and then the tea will be prepared and you're offered to serve. Okay, in this way you will be making a good tea. Okay, now in order to decide that whether your tea is actually good or bad, right, other than tasting yourself, what will you do? You will basically go and serve it to the other people in your family, and you wanted to take the reward from it. Okay, and then they will tell you that whether you should like add some extra cup of ginger or sugar or milk or something like that. Okay, so in this way you actually learned it by some kind of a simulation technique from the external world, right? And in this way you try to update yourself, and then by the time goes, right, so you started making a good cup of tea, right? Again, so you're actually making a good cup of tea at the very first step. Congratulations. But it generally does not happen, right? So for me, I think it took like 2-3 times in order to like get a good feedback from my family that whether I able to make a good cup of tea or not, right? So again, coming to the point, let's say that I have something called as these many amounts that I have actually taken, right? So some like something in grams, right? And these many things I have actually taken and actually like intermixed everything, right, in order to make a tea, right? Now in order to make a tea, right, so now these are actually what, these are basically my input. Okay, and I actually intermix everything. Okay, and I wait for some time, right, and I will get some output. Okay, right, and based on this output, right, I need to again change like these kind of amount to make it a good tea, right? So this is the entire concept of like how the neural network is actually works. Okay, to be very simple, because I don't want it to prolong this lecture for a longer period of time. My intention is to make as easy as possible, make things as easy as possible for you. Okay, so what is actually the input neurons? The input neurons is basically your this one. Okay, that whatever the set of problem that you're getting, right? So on the set of problem, whatever the inputs that you're actually taking, right, some different inputs that you're actually taking, that is basically like make the problem suffice enough to get you a good kind of a predictions, right? Now that if you just combine everything, you started making a whole skeleton of neural network. Okay, and these are the building blocks. So these are basically the neurons, correct? So let me just, yeah, so these are basically the neurons, right? So these are actually the neurons. In this way you started like making something good. Okay, and these are basically the interconnected to each other, right? So it means for now just understand the keyword. Okay, so these are what, these are basically my input neurons, correct? Right, these are basically my input neurons, and these are actually the hidden state. Okay, it is also a neuron. So all set of the small thing that whatever you're seeing, these are basically the neurons. Okay, the same neurons that like our brain cell works, right, the same way, these are basically the neurons. And these are, let's say, edges, I would say, right? And these are basically the hidden layers. Okay, and hidden layer also contains some kind of a neuron. Again, these are the edges, right? And then these are actually the hidden layer, right? And then this is also a neurons. Okay, so in this way the entire skeleton of neural networks work, right? Now let comes to the another topic, which is like backpropagation. Now why it is actually important, as I told you that whenever you're actually distributing a cup of tea, right? So let me come back again. As I told you that whenever you're actually distributing some cup of tea to your family member, right, so you will definitely get some kind of a feedback. Okay, and the feedback that you're actually supposed to get, right, That feedback you think by yourself, and then you try to increase some kind of a, let's say, the amount of tea, amount of sugar, okay, whether you should add a very less sugar or more sugar, it actually depends, right, in order to make a very suitable cup of tea, right? So in this way, how you actually do that thing, right? So you started like iterating it via reverse direction, which means that whatever the feedback that you're getting, right, whatever the feedback, the output feedback that you're getting, right, you try to like back loop it, okay, and then go to the very forward layer, and you try to increase your weight. When I say increase your weight, it means that increase the weights of the input neurons, okay, these are basically my neurons, correct? And don't worry about it if you're not getting anything now. As the lecture go, you will understand each and everything, this much I can guarantee you, right? So what is actually backpropagation? So backpropagation is nothing but, if you try to understand more practically, so it is just that you're actually taking the feedback, right, from your, let's say, output network, or whosoever is actually giving you the output, in order to update the weight, so that next time you try to give the output in a more probable manner, right, so that you could able to make a good cup of tea, right? Now let's summarize it into the mathematical form, like how actually the entire mathematics work, okay? And just like stay with me, it's not a very like hard mathematics. I think you could have understand if you like followed me till now, you could have understand everything. Now when it comes to like summarizing it into the mathematical problem, so I have just written three equations, right? The first is basically the z value. Okay, now what is actually the z value? So z value is like, I have the weights, okay, and then I have something called as x1. I have a weight 2, I have something called as x2. I have weight 3, I have something called as x3. Now what does that mean? So here x1, x2, x3 are my input thing, like are my input neuron. Okay, so let me just do it something like this. Let me use something like this, and let me make the first neural network. Okay, this is my first neural network. Now what will happen is that, because suppose that this is your tea, this is your milk, okay, and this is your, let's say, other ingredients, okay, you are actually adding it with some proportion, okay. Let's say that tea, you are actually adding some, let's say, 20 gram of tea, or let's say very little amount of milk, and then let's say some other ingredients which is like represented by weight 3, right? Now if you just try to combine it, it means that you will be getting x1w1, or let's say x2w2, or let's say x3w3. Okay, am I correct? Right, now this is what, this is basically the combined neuron, okay, which means that if you come to this neuron, right, if you come to this neuron, so what will you do? You try to like do the entire summation of all the proportional inputs that you have actually taken. Okay, similarly, just the example that I given to make a good tea. Okay, so here this is your, this is the part, like you will start making and mixturing everything into a one input neuron. Okay, and this is, let's say that you wanted to represent it using something called as z. Okay, now what will you do? Now it will go and it will try to like give you some output, like the y dash. Okay, y dash, which means that, let's say, prepared tea. Okay, prepared tea, I would say. Okay, now your tea is getting prepared. Now if your tea is getting prepared, now you wanted to test it, right? You wanted to test it, so what will you do? That, let's say that you will go and contact with some experienced person, okay, who is like experienced in making the tea. So simultaneously he will actually started making the tea with you. Okay, and let's say that he started making a tea which is like t1. Okay, t1, right, and this is your tea, right, which is like t1 dash, right? Then you wanted to compare, okay, you wanted to compare your tea with this, with the experienced person tea. Okay, similarly, let's say this is actually y and this is actually y dash. Okay, so can you write the error term? Can you actually write the error term is y minus y dash? Okay, because this is just an absolute difference between a good tea and the absolute tea, like between a good tea and the tea that you have actually make in the very first go. Okay, and because of this error, or because of this feedback, right, you are supposed to update the weight. That is why I'm telling you, you are supposed to update the weight. Okay, these are actually the weight matrices. So you are supposed to update the weights, weight 1, weight 2, weight 3. Okay, and you try to add some more gram of sugar, some milk, some other ingredients, right, and some garlic and some other things, right, to make a good cup of tea, right? So you will be like start iterating every weight one by one, and then you start getting all these things. I think these things you already know, right, because this is my learning rate, right, and this is basically my error part, right, and this is basically my old weight and the new weight, right? Anyway, I will again like iterate it, like try in the later video, so that you will again get a good glance of it, right? So this way, I would say the entire like the architecture of neural networks work, right? And sometimes it is also called as perceptron. When I say perceptron, it means that whenever you have a hidden layer, because I already told you, right, these are basically my hidden layer. Okay, these things are basically my hidden layer. So let's say that if I have, let's say, one hidden layer, what does that mean? Understand the keyword, guys, right? So if I have this hidden layer, so can I say that this is a perceptron? Okay, now suppose that if I have, let's say, more than one hidden layer, right, something like this, right? So let's say that something like this. So suppose if I have a neural network which is like just a input can be anything, right? And then let's say that this is the another layer, this is my another layer, this is my hidden layer. So this is my hidden layer 1, this is my hidden layer 2, and let's say this is my input layer, right? This is my input layer, and then this is like my output neuron, right? Output neuron. I hope you understood till now. Okay, understood like whatever I told you till now, right? And you started connecting every edges to every node, and you started making a good kind of a paradox. Okay, and you wanted to like named it as multi-level perceptron, or simply similarly a skeleton of a neural network. Okay, so you can actually write multi-level perceptron, MLP, or simply a neural network. Okay, and suppose if I have only one hidden layer, so I should probably call it as a perceptron, right? Now let's come here, this part. So this will actually give you more glimpse about what is actually the perceptron part, right? So this is basically give you like the more about the perceptron. Okay, so perceptron, as I already told you, that you have an input which is like the x2, which is, you have the x1, then you have some kind of a weight. Okay, and then you actually doing the summation of all this weight, right? And then you wanted to check that whether your output is actually good enough or not. If it is not, then it's supposed to find out the error. Okay, now as you can see that this is actually my function. Now you can definitely ask me that what is this function, right? So as I told you, it can be any function, but here we named it as an activation function, right? So activation function, what does it do? Okay, now just think it more logically and more like in a very understandable manner. So let's say that if I having, again taking a tea example, right? So if I'll be having some kind of a, let's say, tea leaves, right? And let's say if I having some kind of a milk, okay, I'm actually adding it, right? So can I write the equation something like this? Can I write w1x1 and then w2x2, right? And can I pass it into this function? So can I tell you that, can I use the probability function? And when I say probability, you already know that I am talking about sigmoid function, right? Because I need a output threshold, which I wanted to benchmark that whether if it is greater than my output threshold, then it is a good T. If it is not greater than my output threshold, then it is a bad T. Okay, because there has to be some kind of a decision person at the very end of the layer who could basically tell and decide that whether I am actually making a good cup of tea or not, right? So in this way, what I'm supposed to do is that I will be actually using some kind of a softmax function. Okay, as you can see that basically when it comes to softmax function, what is that? Let's say that it has to be some kind of a linear separable line. Okay, and then it would able to classify that whether my data is basically belonging from this direction or that direction, like that side of the line or this side of a line, and based on that it will also able to give me the probability, right? Again like doing the mathematics of this one. So let's say this is my theta value, right? Theta is basically, let's say, threshold. Okay, so let's say that if my z value is actually greater than, then it is actually belonging to class 1. If it is actually less than, then it is actually belonging to class 0, right? And you can also write this. Now can I also write this, right? Can I also write w1 of x1 and w2 of x2 minus theta? Can I write like this? Correct. Can I also write in a equation of line like this? Agree, right? Now because it is a equation of line, so can I draw the line like this? Because it has actually having a negative slope, right? And because I am able to draw this line, can I say that it is actually mostly working on this linearly separable data? So if my data is actually some kind of a linearly separable, so can I able to like just draw this line and able to like make it correct? So this is the way of like perceptron, like this is how the perceptron defines, like somebody actually defines the perceptron. Now just think about it, that what should be the limitation. Just think it, just pause the video and just think that what should be the limitation of it. Can I say that a limitation is like, I have the data of actually two class, right? Suppose if I have the multiple class, can this one single line is able to like dissect, or can this one single line is able to classify the multiple class? Of course not, right? Because we need more lines, right? So in that case, our single layer perceptron fails. Why? Because as the data representation, in the data representation, as the data started increasing, we need more class. When I say we need more class, which means we need more number of hypotheses, or we need more number of line, right? So of course this single line would not be able to do the good classification, right? So what is the limitation? Can I say that it basically fails, right? It basically fails when I increase the data size, or let's say classification classification size. Can I say like this? So this is basically the one of the limitation of this single level perceptron. Now we move forward to this multi-level perceptron. Okay. So what is this multi-level perceptron? As I already told you that in multi-level perceptron you will be having more than one hidden layer. It could be anything. Okay. So again, taking one example, if you wanted to make a good tea or bad tea, so this is your input, and based on that, these are basically your hidden layers. Okay, and these are actually the weight assigned to it, right? And then these are actually the divergence and convergence, right? So these are actually the conserving everything, and then we are actually giving it to some kind of a activation function, and then we are actually getting the output, right? Now let's understand something called as forward propagation in multi-level perceptron, or let's say artificial neural network. Okay, and this is also very easy because you would actually understood it now. Now let's try to like dive it more mathematically, like what does it actually say, right? So when I say that I have the input which is like x1, so can I say that I have the input like whatever the input, right? I have x1, x2, x3. Okay, just understood in this way that these are the input. Okay, which means that these are the input parameter that I have. Based on that, I wanted to make something called as multi-level perceptron, right? So how do we actually start making? So in layer 0, I will be first assigning these things 1, 2, 3, and don't worry, I will show the implementation of it like along the video. As the video comes to an end, I will show the implementation of each and every part of it. For now, just understood till now, whatever till now I have said. Okay, so these are basically my inputs. My input can be anything. Okay, so let's say here you can actually take the example by yourself. So I'm actually taking the input as x1, x2, and x3. Then what I'm going to do is that I'm actually making the one hidden layer, right? So this is my layer 0, and then this is my layer 1, and then this is my final layer, right? Can I write something like this? Because I need to connect, right? Because it is actually connected graph, right? So I need to connect every weight to this node. So whatever the layer node, right? So this is actually the layer node, the first node of the layer 1. Can I say like this? And this is basically the first node of the layer 0. Can I say like this, right? So can I just attach this first node of the layer 1 to all the node of the previous layer, like this one, this one, this one? Can I attach these things? Agree? Why I wanted to attach? Because this is actually kind of information transmitting. So this neuron has to know that what are the weight actually assigned to this to this neuron via the output of the previous neuron. That is why this is very a conventional way. Similarly, if I go and just ask you like this, that like in the input neuron 2, whatever the weight that I'm, how many weights that I should get the number of edges, right, pointing to as an input of the second neurons of the first layer. Can I say that it is actually this one, right? Can I say this one? Can I say this one, right? In this way you started like fixing your first layer. Okay, so yeah, so you actually build your first neuron. Then at the very final neuron, what will be having? Tell me. So in the final neuron, can I have because the final neuron, these are basically becomes the input. Okay, so for these two neuron, these becomes input. For these layer, this becomes input. For these layer, this becomes input. For these layer, this becomes input, and for these layer, this becomes input. Okay, so these layer is actually having a 2 input, right? So can I just connect with this in neuron into this neuron, right? And this is how like our brain cell also kind of works, right? It works more vaguely, right? Because each and every neuron has to surpass the information, right? And because each and every neuron has to surpass the information, it means that each and every neuron has to be kind of fully connected, right? If I'm just talking about this neuron, so this neuron has to be fully connected to the other two neuron. Okay, similarly something like this, right? So in this way, these are actually the weight. And can I say that these are actually the weight W11 of first layer, W11, W of 1 2, and then W of 2 1, and then W of 2 2, right? And then W of 3 1, and then W of 3 2. It means that W of 3 1, which means that the W3 of the layer 0 is actually like going as an input of the first neuron of the layer 1, right? Now let's try to represent it in a matrix format. So can I write something like this? Can I write the input as x1, x2, and x3? Can I write it? Can I write? Yes or no? Right? So let me use some other color. Right? Can I write the input like this? These are my actually the input, right? And can I write the, let's say, the weight matrices? Suppose if I ask you to, can you just represent the weight, all the weight matrices that you actually verbally tell it in the previous in the previous neuron? Can you just try to represent it into the matrix representation form? Can I actually write it, right? So these are my basically the first row, right? So the first row is basically the weight of W11 and then weight of W12, which means W11 and W12, right? So these are basically the layer 1. So in my layer 1, what will be my weight, right? So my weight will be something like this, that these are my w11 and then these are my w12. Okay, similarly for let's say for second layer, right? So for second layer, so I'm actually getting from the second node to the first neuron, right? So just try to understand that these are basically my first node, right? So first node, I'm actually getting it from the first node, I'm getting it from the previous neuron as this one, this one, and this one, right? Like this one, and then this one, correct? Right? Similarly, if I just understood about this one, so I'm actually getting it from this one, then this one, and then this one, correct? Right? And because it is actually having a two node, right? So that is why I have a column 1 and column 2, because it is actually representing the number of nodes you have, right? So can I also represent something like this? And these are basically the bias, right? So bias is something called as the extra node. So let's say that w1x1 plus w2x2 plus w3x3, and then something called as bias, right? That is why it started representing a single form of equation, that's why, right? So because it has two input, it means that it has two bias, b1 and then b2, right? So it is basically like the biases, right? So it is basically two column, right? And can I combine the matrix like this, right? Can I combine the matrix like this, right? Now after doing the combination, can I also like segregate the weight part? Like for example, let's say that can I just after combining, let's say that I wanted to like add it to the bias model, right? Can I actually write it like this, right? Because these are my basically my input 1 and these are basically my input 2, right? I'm doing nothing, right? So I'm just actually like adding it, right? So can I just from w11, so let's say that it is basically, so it's basically like w11, right? So it's this row is actually having, let's say the first row, and basically it has actually three column, right? The first row it has actually three column, and then let's say the second row is also actually having a three column. So can I just add column wise to this one, b1, then b21, then b31? Can I add like this? Can I add this one with this column, right? So yeah, can I actually write something like this? Okay, and if you're actually wondering about that, how it is like how it is actually adding, because these two are the different kind of a dimension, nothing, you can just take the transpose of it, right? You can just take the transpose of it, so that it becomes the same kind of a dimension. Okay, so 2 cross 3, it is also, by taking the transpose, it will also become 2 cross 3. Okay, and then you would actually probably end up with this kind of equation, right? And bias is like almost like tending to 0, right? So can I also make this as a 0? So these things become 0, and then these things become also 0, right? So these are basically my final input, right? So these are basically my final input. Now let's come to this part. Okay, so these are basically the summation value, as you can see that thing, right? Let me, yeah, so these are basically the summation value. These are basically the summation value. Now what is the value of this one? So this is actually the output of the first layer, right? Because these kind of the entire handling, right? So this is actually happening in these two layer. Okay, which means that the summation at the layer 1 of the first neuron is actually like happening here, like the computation start happening in this neuron, right? So what would be the computation? Again, let's iterate it one more time. Okay, so the computation, can I write the computation like this, which means that x1 and then w11 of 1, right? And then can I write the x2 and then w21 and then 1, and can I write x3 and then let's say w31 and then 1, and can I just write at b1, right? If I just making it b is actually equal to 0. So this is basically the output of this neuron. Okay, the output of this neuron, if I say the output of this neuron, which is like 1. So can I just write output of, let's say, neural network 1 of layer 1, right? So can I just write like this, right? Can I just write it like x1 w11 of 1 plus x2 w21 of 1 plus x3 w31 of 1, right? So this is basically my output. Okay, right? Now similarly, if I ask you to like, can you also write like this? Just pause the video and write it by yourself, right? So can I also write for the second video, can I also input, can I also write like something like this, correct? Now here there is something called as activation function. Now this I wanted to tell you, right? So now at every hidden layer, right? So whatever the summation that you're actually doing, right? Now once you do all these summation, right? So that summation itself has to pass to some kind of a function. Okay, because the function is actually necessary. Why? Just think about it. Because if you're not using the function, it means that all this neuron is basically converged to a one single neuron. Okay, so there is no purpose of then using the multi-layer perceptron. That is why I am actually using the activation function, right? So again, if someone asks you that why to use the activation function at the very hidden layer, just tell them that if we are not using the activation function, it means that all the neurons are basically converged into the one single neuron. Okay, so that is why. So can I just give the output of these things into the activation layer? So activation also performs in this layer only. Okay, so let's say that this layer 1 is actually having activation, some kind of activation function, and then this layer 2 is also having some kind of activation function, right? So this is the output of my layer 1, and this is the output of my layer 2, right? So sorry, this is the output of my layer 1, and this is also the output of my layer 1. So this is the output of my layer 1 of neuron 1, right? And this is the output of my layer 1 of neuron 2, right? And this actually has to go as an input to the activation function. So can I write as an input to the activation function? Can I write like this, right? Can I write like this, the activation function? These are the AF activation function. So can I pass this as an input? And which kind of function I am actually using? I am actually using the sigmoid function. Okay, and I will also tell you that when to use which kind of activation function. I will also tell you the types of activation function which is like mostly used in the neural network creation, right? So this is basically the input of the second layer. Now please understand that this is actually the input of the second layer. Now what is the input of the second layer, right? So this is basically the input of the second layer, because this is my layer 1, so this is my layer 2, right? So these things is actually like can be considered as an input of layer 2 right? So now these things is basically the input of layer 2, and similarly like reiterate the same process again and again, right? So again, these had some weights. Let's say this will be having some weights, this will be having some weights, right? And the final output of neuron 1s, right? Just understand what is the final output of neuron 1s. Can I say that the final output of neuron 1 would be the activation function of the summation equation, right? Similarly, for neuron 2, it is actually the activation function of the summation equation, whatever summation equation that you get, right? You wanted to pass it into the activation function, right? So can I just name it as some other name, right? Some other, so you can actually write like name it some other thing, right? So can I also name it like x1 and x2? Now this x1 and x2 is now become the another set of input neuron for which layer? For layer 2, this one, right? And then similarly same thing. So you basically like converge the entire thing, right? You basically like converge this thing, the entire thing into this one, right? I hope it clears, right? You, and then for the last layer actually you're doing this, and then again the weights, right? And again you wanted to do the summation, right? Again you wanted to do the summation, let's say x1, and then let's say w11 of layer 2, and then let's say x2, and then w2 of 1 of layer 2, right? And these are basic, and then some bias, so bias is actually equals to 0, right? So this is your final summation equation, and this also has to pass to the some kind of activation function. The same thing I'm actually doing here. Okay, so whatever the activation function of the previous layer, I'm actually passing it here. I'm actually like multiplying with them w11 and w12, which is like this one and this one, right? And then I'm able to like construct, or I should say the compress everything into a one single activation function, right? So this has to be my final output, right? Because see, this is me the activation function of the previous neuron, and then I'm actually adding with some kind of a weight. This is the like the output of the previous neuron, which is now become the input of the last neuron, and then I'm actually adding it with the weight. Okay, and this is basically the bias. So bias, I'm actually like making it 0. So can I just again write the activation function something like this, right? So basically from this, what have you understood? You have understood that the neural network is nothing but it is just a some set of chain of activation function, right? Where you will be having some kind of an input which is connected to some kind of a hidden layer, and then this hidden layer, for each neuron you will be having some kind of a summation value has to pass into some activation function. Similarly for this one, it has some summation value, so it has to some pass of activation function. Similarly activation function of summation value, and again these things can be converged and can be write is 1 2 3 this one, right? Can I write this one? Are you getting it, right? Now let's say again you try to approach this kind of equation, then can you just converge it into this one, right? Now this becomes your input, right? And can you just converge it into one single output? Now this is basically output neuron, right? So what I'm doing, I'm just like doing the like compressing it, like the compressing the first layer into a activation function. Okay, so that this is actually became the input to the next layer. Okay, and again whatever the output of the next layer I'm actually compressing into the activation function. Okay, so that this becomes input to the next layer. Okay, and similarly this is actually my final output, right? So this is nothing but neural network is nothing but the chain of activation function. Chain of activation function, just understand this, right? And actually you can also try it by yourself. So let's say that for now I have actually taken the three neurons, right? Just try it with 4 neurons. Okay, I'll give you one task. Okay, just use this one, x1, x2, x3, x4, right? 1 2 3 1 2 1. Okay, what I want is that, let's say these are the weight, right? You can actually assign the weight by yourself. I'm just connecting it, right? And this is basically fully connected. Similarly this, similarly this one, right? What I want is that I want you to first create a weight matrix. Okay, then I want you to create a weight matrix. Now I want to use the weight matrix into the activation function. Okay, and just go series by series. Okay, now what will you do? First of all, let's say this is my layer 0, this is my layer 1, this is my layer 2, and this is my final layer. Okay, so what would be the output of first layer? Can I say that it is actually the summation of all the input to the weight, right? And again it is actually passing it into the activation function. Similarly, can I say that these are actually the input of the all the weight, and can I also pass it into some kind of activation function? Similarly, activation function. Now these things are basically compress it into. So instead of writing these two, can I write 1 2 3 1 2 1? Can I write something like this? This is nothing but it's just activation function, activation function, activation function. Or let's say the input of this neuron, which is, let's say, input of layer 2, right? So can I write it as again x1 x2 x3 or some other input, right? So again just do this, right? So can I just write it as, for this neuron it is nothing but it is just the activation function of the previous summation, like the previous summation of these 3 neurons, right? Similarly for this one, can I write the previous summation of these 3 neurons, right? Something like this, right? I hope you're getting it, right? I'm just reiterating again. So these two are actually converged into this, again this neuron, and this is basically the activation function, or let's say the activation function of the previous summation, right? This is basically the activation function of the previous summation, and this again I am actually passing it, right? And this is actually my final activation function, right? Or let's say final output, right? So this way you will be start like making the neural network by yourself, right? So I just wanted to so it's your task. First, again, recreate the matrix by yourself. Okay, do the matrix joining operation and everything, and at final just let me know that which kind of activation function are you using, and what is the final output you get. Okay, so then we will again, like in the next upcoming video, we will again brushing up some concept. Okay, I'll tell you about each and everything in detail once again, so that you will get the conceptual understanding of it. Okay, thank you.